Okay, welcome, and we'll be talking about multiplying special cases of binomials. And we'll be talking about a square of a binomial. We already know a binomial has two terms. That's pretty easy. Okay, but square of a binomial is something like this. X plus 5 squared. And some people go, oh, I don't know what to do with that. So what you do is just rewrite it twice. X plus 5. X plus 5. Pretty simple, easy peasy, lemon squeezy. Okay, something as simple as that. Now, real fast, we're going to mess around with these two things, perfect square trinomials and difference of perfect squares. Okay, so I'm going to go over here and we're going to write some examples. So let's go ahead and make our box. Okay, and we're going to actually come up with a general formula, so you can learn to memorize this real fast and be able to do it in your head real fast. We're going to do an example. Okay, so the example is going to be over here. So perfect square trinomials are going to be something where you take, let's say, 2x minus 5, and you're going to square it. Okay, now most people go, oh, just square both those terms, and you're done. But you have to remember, you're not squaring both terms. You're rewriting this twice. So this is 2x minus 5. And then 2x minus 5. Okay? So when we go up and we start doing our Punnett square with it, okay, and yes, I am going to go outside of the actual box I just made to actually do some math. Okay, so this one right here, 2x times 2x is definitely going to be 4x squared. 2x times negative 5 is negative 10x. 2x times 5, negative 2x times negative 5 is negative 10x as well. If you notice, that's a repeat, and then this turns into positive 25. Okay, so this is going to become 4x squared minus 20x plus 25. Okay. Alright, and then we'll do an example of a difference of perfect squares. Now we're going to do the same exact thing, except difference of perfect squares is going to have one has a plus, one has a minus, otherwise they're twins. Okay. Okay. So we multiply again. Now we're going to get the same exact terms for here and here. Well, except this one's going to be minus now instead of positive 25. And then right here, this is going to be plus 10x. And this one's going to be a minus 10x. So when I combine those, that will actually just be canceled out. So I am left with 4x squared minus 25. Need the minus sign. Let's get that down. Minus 25. There we go. Okay. Alright, so if you notice, there's some unique differences between these. Okay, they both have the 4x, and that's mainly because 2x times 2x is going to be the same in both. Okay, so when we're coming up with a general formula for this, a plus b squared, we know that it's just going to be the first term squared. If you notice, the first term is 2x. 2x squared is 4x, and then same thing here. 2x squared is definitely going to be the 4x. Okay, so this one is right here. This is going to be a plus b. We're just coming up with the general terms, a minus b. Okay, so a squared is going to be right there. So whatever a is, it could be 2x, could be 5, could be 19x squared. You just square it for the first term. This is a special case. This is a difference of perfect squares or a perfect square trinomial. Now, if you notice on a difference of perfect squares, I don't have a missing third term. I just have minus 25, and 25 is 5 squared. So technically, all I need to do is square this second term, which is 5, square it, and put a minus sign in front of it, and voila, I'm done with difference of perfect squares. See? Pretty easy. Let me move it up a little bit so you can see it. Okay, so there's actually a general formula for difference of perfect squares. So when you're multiplying two things that you know they're both the same except for minus sign in one and plus sign in the other, you can just square the first term, square the second term, and put a minus sign between, and you're good. Will this always work out? Yes, it will. And if you check it with your stuff, you should be good. So like for example, if we had 3x squared minus 4 times 3x squared plus 4, okay, that is definitely a difference of perfect squares. So all I need to do is go square the first one, 9x to the fourth minus 16. And if you check, if you pause the video now and check it out in your own Punnett square, you'll see that I'm exactly correct. So that's a great formula right there. Okay, now back to perfect square trinomials. Okay, so the first term is always going to be squared. Okay. All right, now if you look at the second term, 5, okay, it's going to be squared at the end, but that's going to be at the end. We have a middle term we have to deal with. Okay. So now if we look at that, that's actually 2 times negative 10. And if we think about that, that's 2 times 2 times negative 5. Okay? So that's a huge thing right there. So if you think about it, okay, I have a 2 and a 5. And this turns into 2 and a 5. Will this always be true? Yes. So what you will actually do is you're going to take that, and then there's going to be always an extra 2, because why? Because there's going to be 2 of them. Makes sense. Okay. So what we're going to do is we're going to have, and this is going to be tricky, we're going to put a plus here for this one, and I'll explain why. 2ab for the second one. Okay, so in other words, we're going to take 2, we're going to times it by the first term, and then times it by the second term, and then we get this middle term. So if we try it out, 2 times 2x is 4x, 4x times negative 5 is negative 20, that works. Okay, all right. Now, like I said before, the last term is 25, which is just 5 squared. Will this always be true? Yes. So you can actually just put a plus of b squared here. Oops, not at sign, but b squared. Okay, now, if you notice, we just did it for a plus. What if we did it for a minus? Okay, everything's going to be pretty much the same, except it's going to be a squared minus 2ab plus b squared. Okay? Right. And so you could actually generalize this as this formula, a, and it's control 241, a is, this is the plus or minus sign, b squared, and this should be a squared plus or minus 2ab plus b squared. Okay, so you could actually shorten down those two formulas to it. Now, what does that mean? This is a shortcut. Perfect square trinomials is not a shortcut, but it's actually a special case of multiplying binomials that you can actually just go ahead and skip to the answer just by knowing some certain facts. So, for example, if I gave you, let's go 5x to the third minus 9y, something complex like this, and then I square it, okay? I'm going to use this one to recognize that it's a perfect square trinomial. So all I do is square the first term. So I square this for the first term. So equals 25x to the 6th. Makes sense? And then I go, okay, minus, all right, and then I go 2 times 5x cubed, which is 10x cubed, times negative, or times 9y, which is 90x cubed y. And look at that, that's really nice. Okay, now this is for a really complex one, I'm just using it as a shortcut. And then the last term is just going to be the last term squared, which is this 9y, so that's going to become 81y squared. Okay, oh, plus. I need to have the plus because I need the sign. Okay, and so if you check out with your Punnett square this exact method and you do it just like up here, you should see that it just works out that way. You should get two negative 45s, and then the 81 y squared should pop into play when you do the Punnett square. Okay, Alright, but that's it for multiplying special cases. We'll learn later how to go backwards. It's really cool. I'll talk to you guys later. Bye.